At this point, we're now on circuit 1D, RGB night light. So we do have a new component. It's called an RGB with some old components, some potentiometer, a photoresistor. So something very unique about this RGB is that it has 4 legs, all right? It has 3 legs being used to produce 3 different colors, which then combine to create an infinite array of colors with different brightnesses. Just notice that each of the 4 legs has a unique function. Your longest leg will be used to be connected to ground. One of these legs is for your red color, another one is for your green color, and then your blue color. Make sure you install your RGB as shown here. So I'm going to make sure I spread my wires. Our potentiometer is on 15B, 16B, and 17B. I'm going to analog input A1. So notice our jumper wires for our RGB are going, for the red color is going to pin 9, our green color is going to pin 10, and our blue color is going to pin 11. We need to get rid of this LED. We need to include our 10 kilo ohm resistor. So the unique thing about this code is that when we cover our photoresistor, our RGB turns on, but notice we get a variety of colors once we turn a potentiometer. So as we turn the potentiometer, the color of the RGB will change, and at a certain value, our RGB will turn on and off depending on our photoresistor's value. So let's cover it, and it turns on and off, on, off, on, off. So now we have 3 integers. In this situation, these are just placeholders. We have a photoresistor, a potentiometer, identified as having the same value as whatever value we produce from pins A1, and for the photoresistor A0. And then threshold will just hold the value of 700. Lines 20 to 22 are identifying these terms also as integers associated to these pins here. In line 24, void setup, we are communicating once again with our serial monitor, and then we identify these few pins as outputs so that we can send electricity to these specific pins here. In void loop, we are repeating this code over and over again, and in line 35, we're just saying, hey, photoresistor is equal to whatever value we have in analog 0, and in potentiometer, we're saying that it is equal to whatever value we get for analog A1. Notice we have 2 analog inputs, all right? So instead of being in a state of being on or off, we have a variety of values to attribute to these 2 inputs. In lines 38 to 41 with the serial print functions, we are now printing out these terms and these values in our serial monitor. And you can actually change these terms right here in between the quotation marks, and you'll be able to see something else like your name, your dog's name, your parrot's name, whatever you want to put there. In line 43, if the photoresistor is less than the threshold, remember threshold is this value 700, then our RGB will perform this function here. If it is not, then the RGB will turn off. Now that our photoresistor is less than the threshold, we activate this section of the code here with a bunch of if statements. So in this situation, these if statements are now associated with the condition of the potentiometer having values in between certain regions. So if our potentiometer reading is greater than 0 or less than 150, we're going to show a color red. So let's see. Our potentiometer is now at 300. Let's make it go down to 150 and let's see what happens. And it turns red. So now if I go up between 150 to 300, we see the color orange. This may be difficult to see because my room is pretty bright right now, but that's our supposed orange. And then if we keep turning, we can get all the way to green if we're in between 450 and 600. And this code is pretty much being repeated every 100 milliseconds. Our computer does not know what red is, it doesn't know what orange is, it doesn't know what yellow is. So what Sparkfun did is that I created a function for the name red, for the name orange, and every other color here. When we have our potentiometer in the region of red, what's really happening is that our Redboard is sending electricity only to the red pin because this is what is written in the code. This function called void red, that's in between these 2 brackets, we are only sending electricity to the red pin. For orange, we send electricity to red and green to create that color. If we go down to cayenne, we send electricity to green and blue, but not red. We also have a turn off function to turn off the LED and make sure that there is no electricity going to any of the pins. For our first challenge, we need to add a new color into our circuit. So we're going to be working with our analog writes and our if statements for the potentiometer. So the potentiometer has bytes going from 0 to 1023. And the potentiometer is in between 0 to 150, it is red. In between 150 and 300, it is orange. So that's what we see here. And from 300 to 450, we see a yellow. So in this situation, I'm going to add a new color that is going to be called Cobian, and it's going to be between the ranges of 500 to 600. So to add this new color in between 500 and 600, I'm going to copy this here, Control C. I'm going to hit Enter here. Reduce this value to 500, and this value over here is going to be at 500. And the reason we're doing this is that in between 450 to 500, we still have the color green. But in between 500 to 600, we have our new color, which is going to be called Cobian. The code is case sensitive. Then you need to be consistent throughout your code, and you need to make sure that Cobian in this case has a capital C and a capital B, but that's ridiculous, so I'm going to take that off. Cobian is not a term that the computer understands. Now that we need to identify what pins will be activated to create this new color with the RGB. So we can just go ahead and copy any of these. So I'm going to copy this part and paste it below. You can also go ahead and type this out. You can do void, Cobian, parentheses, open bracket, enter, and then notice how it creates that closed bracket. We need to have these brackets closed, and then you can write out the rest, but I don't really want to right now, so I just copied and pasted. 255 is a maximum value that we can have for our RGB, and once again we need to type in Cobian here. So right now I'm at 450, and this is still my green color. So now I'm going to go up to 500, and we get this very bright color. So now we're mixing all the colors at a full brightness. This is very bad for your eyes. Don't stare at that. So that's pretty much how you solve challenge 1. So the lowest you can go is 0. The highest you can go is 255. Try changing these values up and see what colors you get. We want to create multiple colors when our potentiometer is in a certain range. At the moment, if we cover our photoresistor when our potentiometer is in the range of 0 to 150, we get the color red. At this point, I'm going to change this up so I can see a blinking pattern between red and blue. So we're going to start off by putting a delay. So we can only see red for 500 milliseconds. Then we add blue, semicolon, and then we put a delay. So we successfully see red and blue. However, when we turn the potentiometer to get other colors, for instance yellow and blue, is blinking. We don't want that. So what we need to do is add some brackets. We're going to add another bracket here. So notice these two brackets are closing each other. Now we only see a green. When I go down to yellow, we only see a yellow. And we go to red, we see red, blue, red, blue. So go ahead and try to make your own pattern, and maybe you can even use this to blink a message using Morse code. We're going to be using the potentiometer to change our threshold. So in this case, we can manually change the threshold and adjust the lighting with the knob. So in this situation, for our RGB to turn on, we need to cover our photoresistor so that our reading is below 700. 700 is a fixed amount because threshold equals 700. And we're going to change the threshold in void loop. We're going to write out threshold, and we're going to set it equal to analog read A1, which is a reading for the potentiometer. So this is one of our first errors that we see. Threshold is written incorrectly. It's thresholded with an R. So let's fix that. And I just realized that analog is missing the read portion. There you go. Notice how the color changed. And it automatically turned off. Notice I didn't cover the photoresistor. At a higher reading for the potentiometer, our RGB turns on, but at a certain point, it turns off. We have made the potentiometer change the threshold. Challenge, we need to fade an LED. In the first one, identify the position in which I will be fading my LED. I'm going to put it in between blue and magenta. Let's copy lines 64 and 65, paste it. This is fine right here. Blue will now be between the ranges of 750 and 800. And our faded color for red will be between 800 and 900. We're going to call this fade red. So now we need to create our color, our fade red. Let's go all the way to the bottom. I'm going to copy this. Put that in line 40. line 140 will be the beginning of our new faded color, fade_red. So red, if you recall, is only receiving electricity and nothing else receives electricity. Now we need to put a delay. So I'm going to put a delay of 100 to make this code go quick. Now let's just copy all this. Red pin 200. Copy that, so we have 250, 200, so our brightness is decreasing. Now we go down to 150. We have a value of 100. We just need 2 more values so that we can also turn off our red color. So we go down to 50, and then finally we have 0. Our brackets are also closed, so we click on this bracket right here. We notice that it is closed with this bracket on line 177. So all of this code right here belongs to void fade red. In this situation, our potentiometer has a value of 872, which is in between 800 and 900, which allows our fade red code to initiate. Our RGB is fading the red color.